Now, moving on, there are two branches of artificial intelligence. Let me explain them one by one. The first branch of artificial intelligence is symbolic systems. What are symbolic systems? They represent knowledge in symbols, such as words or images, and manipulate these symbols using rules and logic. In a symbolic AI system, knowledge is often represented using logical statements, which are used to reason about the world. When I say logical statements, if you come from a mathematical, statistical, or technical background, you might recognize Boolean expressions. These include conditions like and or, which can be combined to create logic. For instance, if you've studied logic and the scientific method, you're familiar with Boolean expressions. These expressions are also used in programming to create prototypes of computer programs before coding them in a language. Boolean expressions like if conditions, and conditions, or conditions form the foundation of logical statements, which we use to build sequences or algorithms. A symbolic system uses these logical conditions to make decisions. For example, if A, B, and C happen, then perform action D. This is the basis of how symbolic systems operate. As complexity increases, these logical statements are layered to form what is called a rule-based decision support system. My first exposure to such a system was around 2007 or 2008 when I worked at roomsnet.com, my first digital and e-commerce job. The engineers there developed a rule-based decision support system to simplify decisions regarding Google Ads bidding. Today, Google handles much of this automatically with AI, suggesting when to adjust bids. Back then, however, we had a straightforward symbolic decision support system built by engineers. They observed our decision making process, documented it, and created a logical rule system that was converted into computer code. This system saved us considerable time by automating calculations needed to decide whether to increase or decrease bids. These systems are based on logical sequential rules and are excellent examples of symbolic systems. The second branch of AI is neural systems or neural networks. A neural network is a computing model inspired by the structure of neurons in the human brain. Unlike symbolic systems, which rely on predefined logic, neural networks identify patterns in data through a process called training. This training involves feeding the network large amounts of varied data, allowing it to learn patterns and make predictions or decisions without explicit programming. For example, consider Google Maps. Over the years, Google Maps has become highly accurate in predicting travel times. This is achieved by collecting data from millions of users, analyzing routes, driving behaviors, speeds, and traffic conditions. Through this continuous learning process, the system becomes better at providing accurate predictions. Neural networks differ from symbolic systems in that they are not bound by predefined logic. Instead, they learn from data and improve over time. This capability allows neural networks to handle tasks like image generation, language translation, and content creation. AI can also be categorized into narrow AI and general AI. Narrow AI is designed for specific tasks, such as navigating a car from point A to point B or optimizing Google Ads. In contrast, general AI can think and make decisions like a human. However, general AI remains a hypothetical concept as of now. With advancements in large language models and neural network technologies, we are moving closer to achieving general AI. Examples of symbolic AI include rule-based email marketing systems, where specific actions, like sending an email, are triggered by defined conditions. Other examples include programmatic media buying platforms, rule-based chatbots, and text-to-speech or language translation tools. In contrast, neural AI powers tools like ChatGPT, which uses large language models, and generative AI platforms like DALL-E or Midjourney for image creation. These systems rely on machine learning and self-improvement through training, making them more flexible and adaptive. Understanding these branches, symbolic systems and neural networks, and their applications in narrow and general AI is crucial as we continue exploring the world of artificial intelligence.